So today, a big thing we're going to do in chapter 4-5 is we're going to analyze the graph of a rational function. All right, so we're going to basically walk through these steps. This is how we analyze. We find all this info, okay, and then we take a look at the graph. Now, if this was in class, we'd be graphing by hand. So I am going to show you how to graph it by hand. But the nice thing is my math lab does not do graphing of rational functions very well. So basically what they did is they gave you 4 different graphs to choose from, and you have to match up which graph looks like the one you see on your calculator or the one you did by hand. Okay, so that's what we're going to do today. Walk you through. I have a little cheat sheet as we go through, and you might want to take a picture of that or write this stuff down. So again, hopefully you get your notes out. So let's get that out. And then let's get started. The first thing I want to do, for example 1, I want to graph it. I want to graph 3x plus 3 over 2x plus 4. So let's go ahead and graph that. So grab your calculator if you don't have it out yet. Grab it. Okay. Now you have a couple ways that you can do this. Number 1, if you're going to graph this using your calculator, please put parentheses around your whole numerator and whole denominator. So if you have multiple terms, binomials, trinomials, what have you, again, parentheses above the 8 and the 9, and I have 3x plus 3, close it, divided by parentheses 2x plus 4, close it, okay? I would also have y2 is 0. So I have parentheses 3x plus 3, close it, and then divided by parentheses 2x plus 4, and then have y2 is 0. Now another way that you can type in this function, example 1, you could do alpha y equals if you have a TI-84. And that's where you press number 1, and that sets up the fraction, and then you don't need parentheses. You can just type it in like you see it, 3x plus 3 and 2x plus 4, okay? So you could do either one if you have an 84. The nice thing about this one, if my math lab is asking for an exact value, when you go second trace value for x, you can plug in an x value, and the y value that you get back is going to be a reduced fraction. Versus in y1, if you were to second trace value something in y1, that would be a decimal. So you got to see what my math lab's asking you for, and if you have an 84 and they want exact values, I would probably use this guy here, y2. Okay, and I'll show you the difference between that, but not with this example. So again, I'm going to make y2 0. That is, again, our x-axis, and we're going to graph this thing. So we're going to go ahead and graph. I'm just following what it says, graph R using your graphing utility. And then we're going to find our domain of a rational function, okay? So this is the graph I have. I'm in Zoom 6 when I graphed it. And if you're not getting this graph, let me know. Again, everybody should be graphing this thing, not just me. Everybody should have your graphing calculator out. So now we want to find the domain. Remember, domain is where the bottom can't be 0. All right, so maybe make note of that. Domain is where the bottom can't be 0. So I take a look. Bottom can't be 0. Okay. So if you need to, set that equal to 0. Domain is a set of all real numbers such that x cannot be blank. One thing you can do to help you answer that question for domain is you could always try to factor it. You can take a 2 out. Well, GCF. And now we can't have what? What makes the bottom 0, y'all? X cannot be 2
or -2.
Yeah, in this case, -2. Okay. This 2 you don't care about because it doesn't have an x value, but this one set equal to 0, subtract the 2 over. You can't have -2. Okay, and that's from our bottom. Okay. You could also set 2x plus 4, subtract the 4, divide by 2, you get -2 that way. You have two different ways to do that. Okay. Step number 3 is write in lowest terms. I tried to factor the top and bottom, but nothing cancels out. So it basically is in lowest terms. There's nothing else to do. Okay. Locate x and y intercepts. Okay, so x intercepts. I'm going to show you two ways to do this. X intercepts, y intercepts. X intercepts are when y equals 0. And y intercepts are when x equals 0. Okay. The easy one to do is the y-intercept. The y-intercept, I can look at the original function and plug in 0 for x. And basically, I use the cover-up method. Anything that's an x, I cover up, and whatever's left as your constants, 3 and 4, is your y-intercept. So I get 0, 3/4. Okay. Your x-intercepts are where your y is 0. Okay. So we don't have a y. This is r of x equals. That's the same thing as y equals. If I'm doing this by hand, I got 0 equals 3x plus 3 over 2x plus 4. So if I'm doing this by hand, this is what I'd have to do. Think of 0 over 1, and now most people would just cross multiply. Well, 0 times 2x plus 4 is still 0, and now I get 3x plus 3. Okay, so the hint here is x-intercepts are zeros of the function. Okay, if you have zeros of a function, you're looking for where the top is 0. So always remember ZZ Top. You guys remember ZZ Top is an old rock and roll band. They have big long beards all the way down to their knees. So always remember, just set your top equal to 0 and then solve it. You would subtract 3, -3 equals 3x, and then divide by 3. You get -1. So the x-intercept that I get is -1, 0. Or your 0 of your function. Okay. Now, would I do those by hand? This one, no. I'll show you how to use your calculator. Okay. So, x-intercept, have to have y2 as 0. We know how to find x-intercepts in our calculator. This is what I would do. I would go second trace, intersect. Okay. Now, make sure your first curve is on the blue one, right? Make sure it's on this side of the asymptote. So I go first curve, enter, second curve, enter, guess, and I jump to -1, 0. That's pretty much how I would solve this one. I would not do it by hand, but it's an option. And we got the -1, 0 for that. Okay. And then last but not least, if I want my y-intercept, second trace value, plug in 0. Then we get 0.75 or 3/4. So either one works. All right, so I'm going to graph those guys. So I got -1, 0 is right here. And then 0.75 is just up 3/4 of a box. So right there. So I've got my x and y intercepts graphed. Testing for symmetry, I would just do this visually. Do you guys see any symmetry over the y-axis or origin? Do you guys see anything symmetric here? What do you guys think? I'm seeing head shaking no here. I'm seeing thumbs down. This is definitely not symmetric. So I would just say no symmetry. Okay, so test for symmetry, look at it. Okay, x and y intercepts, use calc. I think that's easiest. Vertical asymptotes. Remember, vertical asymptotes, in lowest terms, it's where the bottom equals 0. So if you're looking at vertical asymptotes, that's where your bottom is equal to 0. So let's take a look at your vertical asymptotes, your verts. Okay. So I take a look, this guy, again, doesn't reduce at all. So this restriction in the domain is your vertical asymptote. You have a vertical asymptote at x equals -2. And visually, if I take a look, here's 1, 2. There's definitely a vertical line here going up and down at -2. Okay, so at -2, 1, 2, I'm going to draw in a vertical line. I usually use dashed lines for that. Okay, I'll label it x equals -2. This is my vertical asymptote. Okay. Last but not least, before we graph the rest of it, it says locate your horizontal and oblique asymptotes. So we have to decide, number one, is it horizontal, oblique, or neither? And this is where we look at the degree on top and bottom. Okay, so my rules. These are my little cheat sheet for rules here. Okay, we said n is the degree on top, the largest exponent on top. M is the degree on the bottom, the largest exponent on bottom, and we compare. Degree on top is less than degree on the bottom, then it's horizontal at y equals 0. If n is equal to m, the degree on top is equal to the one on the bottom, then it's horizontal at y equals a over b. It's basically, you're going to have a polynomial, you just cover up everything except for the first two numbers, the first two coefficients. And if n is equal to n plus 1, then we have an oblique asymptote, and we use long division to find it. That's at y equals mx plus b. Okay, so when I take a look, I look at the degree on top and bottom. So I just usually go right here. What's the degree on top? What's the degree on the bottom? What do you guys got for n and m? Degree on top, degree on the bottom. What do you guys see? Chris, McKelvey, John, what do you guys see? What's the degree on top? What's the degree on the bottom? Jess, Gavin, Madeline. Am I frozen? What's the degree on top, guys? What's the largest exponent? What's the degree on the bottom? Yeah, degree on top. The little exponent there is a 1, and that's a 1. They're both 1. So I compare them. N is not less than m. 1 is not less than 1. 1 is equal to 1. So then I have a horizontal at y equals a over b. Okay, so I know n is equal to m. So it's y equals a over b. Okay. Well, what does that mean? Well, just the coefficients that are leading. So basically cover up everything, and it's the first two numbers. Okay, so n is equal to 1, m is equal to 1, n is equal to m. So it's y equals, again, 3 over 2, or 1.5 if you like having a decimal. Okay, and I'm getting these two numbers, this a and b here, is these two guys. So I'm using a highlighter, so where I'm getting this 3 and 2, it's just the leading coefficient on top over the leading coefficient on the bottom. Okay, so again, that's 1.5. So I'm going to graph 1.5. So I'm going to go up 1.5 and just make a little dashed line here. Okay. So I look at my graph. I have enough information about this graph, this part, right? Imagine there's an asymptote, cuts your graph into two parts. I know I have enough to graph this one. It's getting really close to this asymptote. It crosses the x-axis, crosses the y-axis, and it's getting closer and closer. The issue that I have is I don't have any information about this part of the graph, this part. Well, that's what's nice about having a calculator. I can just plug in any values I want. My asymptote is at x equals -2. You can plug in any x value to the left of that. I would probably plug in the nearest integer, so second trace value. Again, if I plug in -2, I have nothing there. It's an asymptote, so I shouldn't have anything for y. But if I do -3, I get 3. So I'm going to plug in 1, 2, -3, 1, 2. So I plugged in -3, 3. If you want to plug more points in, if you want to do -4, you can. If you want to do -5, you can. It's whatever you want to do. Just get a point. If you're doing this by hand, at least one other point to make it a nice, pretty graph. Now, the nice thing is with MyMathLab is you don't really have to graph this by hand. Okay, you definitely need to be able to go through all these steps here. But I would have this in my calculator, and now MyMathLab will have 4 choices for you to identify which graph matches with what you see here. Okay. All right, and that's pretty much done, guys. We're all done with that one. Any questions on this one? Any questions?
Your the equalities, like if it's greater or equal to.
Say that again? Okay, so this is what I'm going to do. I'm going to show you my cheat sheet now.
Yeah, your cheat sheet.
All right, so let me get rid of this. And what you might want to do here, guys, well, you can, if you can't see this clearly, let me know. But you might want to, let me get it so it's all on here. There we go. You might want to take a screenshot of this. Okay? You can screenshot this Zoom, at least I think you can. Should be able to screenshot this and then just put it in a Google Doc if you want. Okay, so if I'm looking for horizontal or oblique asymptotes, I'm using this idea here. My N and M's. If I'm looking for my domain, number one thing I know my bottom can't be 0. So I might have to factor and solve. I usually do my vertical asymptotes next. Remember, that's found in the bottom of your reduced fraction. So if you reduce it, that's a whole. And we'll see that in the next example. Okay. If I'm doing my x-intercepts, make sure you have y2 as 0, or you won't be able to do second trace intersect, number 5. And your y-intercept, second trace, number 1 value, x equals 0, is how we found the y-intercepts. So again, when I'm analyzing, these are all the things I should be able to do. Okay. So again, you might want to snapshot that, screenshot it, put in a Google Doc, put in your chapter 4-5 pre-calc little cheat sheet. All right. Let's move on to the next one. I'm only going to do 2 examples here today. And when we're done, we're done. You guys go with this? Can I move this? Nobody's saying no. 5, 4, 3, 2, 1. All right. Let's put it in action. Let me zoom here. Okay, so I'm just going to walk us through number 2 here. So I've got r of x equals, I have x plus 1, and then x squared plus 3x plus 2. Okay. So if I'm going to graph this with my TI-83, I would use parentheses here and here. If I'm graphing with my 84, I'm going to put parentheses there or there, or I'll show you what happens when you do the alpha y equals. Okay. And again, if you're not getting this graph, let me know. So I'm going to do alpha y equals number 1. I'm going to do x plus 1. I don't have to worry about parentheses if I have an 84 and I did alpha y equals. I've got x squared plus 3x plus 2. Okay, I also have y2 is 0. I've got x plus 1 divided by x squared plus 3x plus 2. Okay. I'm going to go zoom 6, zoom standard. So give me a nice pretty graph here. Okay. And there we go. We got a nice graph. All right, domain. My cheat sheet says, okay, domain bottom can't be 0. All right, so let's do a little factoring. Factors of 2, y'all, that add up to 3. Shout them out. Factors of 2 that add up to 3. Faster you guys answer, faster we get this done, y'all. 2 and 1. So my domain cannot be 0 on the bottom. Domain is a set of all real numbers, except the opposite of what I see. So -2 and -1 are my restrictions. Now, vertical asymptotes, guys, are found in the reduced fraction. And I can totally reduce these x plus 1s. Those totally cancel. And now that gives me 1 over x plus 2. So I have a vertical asymptote at the restriction in the bottom. Oh, sorry, I lost my pen. So again, I have a vertical asymptote at the restriction in the bottom at x equals -2. So again, 1, 2, negative. I'm doing this by hand. Nice pretty graph here. X equals -2. I got a little vertical asymptote. Okay. Now, in chapter 4.4, we said I still have a restriction in my domain, but if you reduce it, you remove it, and like you remove dirt from the earth, that becomes a hole. So we have a hole at a coordinate point, and that coordinate point is -1 something. Now I can't plug -1 in here, and I can't plug it in here, but I can plug it into the reduced fraction. I can plug in -1 into the 1 over x plus 2. That ends up to be 1 over 1, which is 1. So I have a open dot at -1, 1 right here. I get a big old open dot right there. Any questions with my vertical asymptote or my hole? Those are, again, restrictions in your domain. All right, x-intercepts. I would just use my calculator. There's no way I'm going to do this by hand. You can. I wanted to show you that, just good refresher. But let's do it. Number 1, you have to have y2 is 0. If you don't have y2 is 0, you can't do it. But when I do second trace intersect, first curve enter, second curve enter, guess, I get nothing. Right? I get nothing here. It does not touch. It does not touch the x-axis. Right? I get an error message. I could even try it again, second trace, intersect, and try to move it over to the other sides. First curve enter, second curve enter, guess. And I get nothing. No sign change. Okay? Well, it doesn't mean you're wrong. It just means there's none. There is no x-intercepts. Okay? Why do you, looking at this graph, why do you think there's no x-intercepts? Why is it not touching the x-axis? What do you guys think? Horizontal what?
Oblique.
Not oblique. Horizontal. Watch your mouth. No, yeah, horizontal asymptote. Yeah, good job. So there's probably a horizontal asymptote there. And, you know, as I'm looking at this graph, for sure, I think there is. We'll verify that with our little N and M rules. Okay. And ZZ top, look at your reduced fraction. You don't have anything to solve for. You do here. So some people think it's -1, but it got removed and there is no 0 on top. Okay. Awesome. Y-intercepts are again when x equals 0. Okay, my little cheat sheet says I can go second trace value, or I can use the cover-up method and cover up every x, and I get 1 over 2. Okay, or second trace value 0. And this is where if you're using alpha y equals, you can see it gives you a fraction as your answer. So that's kind of nice, especially if my math lab's asking for an exact value. Okay, so I got 0, 1/2, or 0.5. So just 0.5 right there. Last thing we're going to do is find that horizontal or oblique asymptote. Horizontal, oblique. So horizontal or oblique, we look at the degree on top and bottom. N is the degree on top, M is the degree on the bottom. What do you guys have? Sydney, Duncan, Joe, Lorelai, Hayden, Lisa, what do you guys got for degree on top and degree on the bottom? What's the largest exponents you guys got? What's the degree on top? What do you guys got? Duncan, Joe, Sid, John, what do you guys see? What's the degree on top? Help me out, man. Show me a finger. What's the exponent on top? There you go. What's the degree on the bottom? How many fingers? 2. Sid gives me the peace sign. 2. Degree on top is 1. Degree on the bottom is a 2. I compare them. Is 1 less than 2? You betcha. I do have that horizontal at y equals 0. So n is less than m. So it's y equals 0. So it's horizontal, not oblique. Okay, so I'm going to go ahead and graph that right there. So if I'm doing it by hand, it's nice to label these here. Now I really have enough, when I look at this graph, I really have enough for this, right? I have a hole, I got a y-intercept, and then I got my asymptotes keeping me on that side, okay? The thing I don't have is I don't have any information about this side of the graph. Okay, so again, my asymptote's at -2, so I can go second trace value and plug in any value to the left of -2. I would probably just do -3. So -3, and I got -1 right there. So -3, -1. You can use any point you want. If you want to do -4, that's -1/2, -5. Now you start dealing with fractions, 1/3, and so on. 1 point is all you really need if you're doing this by hand. Again, the nice thing, my math lab, for you guys, it really is not good for graphing. Okay, it's really not good for graphing these. So basically all they said was, okay, give me the answers for this stuff and then match up your graphs. Okay, and you don't have to do it by hand. It's just, you know, if this was real world and wasn't Corona time, we would be doing this by hand. Okay, and I'd be testing you with a sheet of paper and you'd have to graph this by hand, but it's not, so we're not. Okay, so it's all just multiple choice for actually matching up the graph. And you should be able to look at your graph here and identify which one matches up. Okay. All right, ladies and gentlemen, that is all I have. I'm going to stop recording.